At the top here, you're going to have a tyrosine that's going to be encountering its buddy tyrosine hydroxylase, the rate-limiting enzyme in this pathway that converts the tyrosine into 3,4-dihydrophenylalanine, or DOPA. When that encounters the enzyme DOPA decarboxylase, or DDC, it then converts the molecule into the molecule of interest today, which is dopamine. If that isn't a hook to a fire video, I don't know what is. Okay, so dopamine is a neurotransmitter that is synthesized in the substantia nigra, the ventral tegmental area, and hypothalamus, where each dopaminergic nuclei project to different areas that lead to different outcomes, and so we thus name each pathway differently. The dopamine system, related primarily to movement and goal-directed motor responses, is the nigrostriatal pathway, where the neurons of the substantia nigra project out to the dorsal striatum, composed of the caudate and the putamen. Next, we have the mesocortical pathway, where VTA dopamine neurons project out to the ventromedial prefrontal cortex, the orbital frontal cortex, and the anterior cingulate cortex, or the ACC, as well as the medial PFC. Its role is reward sensitivity, neural responses when receiving a reward, and ultimately evaluating how much effort must be put in to get the reward. Neurons in this pathway also innervate the ventral striatum, which is a key structure in reward anticipation and reward prediction error. Next, we have our mesolimbic pathway, composed of dopamine neurons coming from the VTA, the ventral tegmental area, that project out to the ventral striatum, especially the nucleus accumbens. The nucleus accumbens has been involved with hedonic responses, so like pleasureful responses, and reward, as well as motivation. While both the mesocortical and mesolimbic pathway have dopamine neurons projecting out to other places in the brain, the mesolimbic pathway is defined by its innervations with structures within the limbic system. So there are dopamine neurons that are innervating with the amygdala, the hippocampus, and the ventral pallidum. Among those structures, I think the amygdala is probably the most important one to remember, where the amygdala is critical for certain aspects of stimulus reward learning. In other words, fear memory formation, or incentive salience, which we'll talk about a little bit later. The way the hippocampus works in this pathway is dopamine signals novelty and strengthens memory consolidation to remember the place or context where the dopamine was released. The median forebrain bundle, or MFB, as seen in this figure here, refers to the white matter tracts that connect the VTA to all the structures that it's talking to in the mesolimbic reward pathway. There is another dopamine pathway that I'm going to ignore today, which is the tuberoinfundibular pathway in green here. And the reason I'm not going to address it and explain it is because I'm going to be focused on the pathways involved in addiction. But what is this neurotransmitter dopamine actually about? At first glance, dopamine is about reward, because there are many pleasurable stimuli that stimulate the release of dopamine from the ventral tegmental area. What's dopamine about? Well, at first glance, dopamine is about reward, because there are many pleasurable stimuli that stimulate the release of dopamine from the ventral tegmental area. Evidence for dopamine being tied to pleasurable stimuli can be seen in how our consumption of things like alcohol, cocaine, heroin all increase dopamine release in the nucleus accumbens. The number one I put next to the Scotland flag, the Scottish flag over there, it was supposed to indicate that Scotland's number one in cocaine use. That's not true anymore, so ignore that drawing. Anyway, when VTA dopamine release is blocked, pleasurable stimuli become aversive. What does that mean? That just means that when dopamine is not able to be released, what was once pleasurable is no longer the pleasurable thing that the person felt before. So no dopamine, no pleasure. Dopamine has even more evidence showing its association with pleasure, wherein people who experience chronic stress or stress over time have depleted levels of dopamine, and the sensitivity for dopamine at their dopamine receptors is decreased, which leads to anhedonia, where there's an inability to experience pleasure, i.e. depression. In people that are hungry, dopamine is released when thinking about food. Show a full person a photo of a milkshake, however, and there's no reaction because they're satiated. They don't want any food because they're not hungry. Show a hungry person the same thing, and you're going to have an increase in dopamine. The mesolimbic dopamine pathway also responds to aesthetic things like new, good, or pleasing music. And when males actually look at photos of sports cars, there's been research that shows that there's dopamine that's released from viewing these sports cars. Now, if we give a monkey a raisin for doing 10 presses of a lever, dopamine gets released in the nucleus accumbens for, let's say, 5 units of dopamine. Now, let's say that you give the monkey 2 raisins for the exact same amount of work, which is 10 presses of a lever, but this time, because the reward is doubled, the reward that is felt is doubled as well. So you get 10 units of dopamine. Now, let's say that we don't change the reward in response to work for a while, meaning the monkey gets 2 raisins for 10 lever presses. The quantity of dopamine will return to the original reward of 5 units of dopamine. Now, if you give the monkey the original reward of 1 raisin, dopamine levels decline. Why? Habituation. Nothing's ever as good as the first time. Now, think to what would happen to us if we took a stimulant that was man-made and cannot be found in nature, like cocaine, that causes the DAT to be blocked, leading to more dopamine in the synapse. Well, we would habituate to this truly unfathomable high, and other pleasures that once had a lot of importance to us no longer seem as rewarding. A great way to understand how the mesolimbic pathway works is by understanding this psychological concept of incentive salience, wherein the individual's behavior is primed to be ready to get things important for their survival. Here is where VTA connections with the amygdala start to make sense. Fear of not having food incentivizes us to get it. The VTA's connections to the hippocampus start to make sense when we understand our brain tying in context to the reward. For example, the signal for the reward, a light turns on, and the monkey goes over and picks up the raisin. With each raisin picked, there's only a small increase in dopamine. The real increase happens when the light turns on. This tells us that dopamine isn't just released when one is rewarded, but particularly when one anticipates a reward. This explains the role of context in addiction, where the memory of the positive feeling in a given place leads to a relapse of the thing the individual is addicted to. Now, imagine that 50% of the time the light goes on and the monkey goes to press the lever. The monkey doesn't get a raisin. Introducing this maybe yes, maybe no, increases the anticipation of the reward and increases dopamine when the monkey waits for his raisin. If you were to change the uncertainty of receiving a reward to 25% or 75%, so in other words, when the monkey becomes less likely than not or more likely than not to receive a reward respectively, dopamine reward decreases. What does the 75% or 25% tell us relative to our 50%? What it's telling us is that there is an increase in certainty that we will or will not receive a reward. And as we can see here, an increase in certainty does not correlate with an increase in dopamine. In fact, what this graph tells us through the 50% green dotted line is that an actual increase in uncertainty as to whether the reward will occur or not leads to an increase in dopamine. Of course, there are some vulnerabilities to addiction that we have to account for. 1, people under high levels of stress, chronic stress, are much more likely to get addicted to an artificial reward, like alcohol or cocaine or heroin. 2, social context really matters. When rats are given drug water alone, they're more likely to use the cocaine drug water than if they were in their colony. Of course, it's still cocaine, so these rats would still go back on occasion to have the cocaine water, but they would do it less so than they would if they were with their colony. Genetics also play a huge role in our vulnerability to addiction. It's thought that individuals who have an increased amount of nicotine acetylcholine receptors, or whose nicotine acetylcholine receptors have increased sensitivity, will be more vulnerable to nicotine addiction because of the higher relative reward they will feel after taking nicotine. If you like this video, please like, subscribe, and comment in the comment section down below. I hope you learned something about addiction today. Peace.